Hello everyone, I just thought I'd do a quick video on the new style vacuum adapters that I've machined and tested. So the old style used to have a slot cut in the bottom for basically a square O-ring, and the O-ring would just simply sit on the top of the stepper motor case. So that would provide a seal to the case, and of course there was a lot of vacuum leakage through the case itself out of here basically. So the new style, I've had these bearings sitting around forever to test this, basically just uses a sealed style bearing. Just to measure them, I think they're 11 by 4, and then the inside diameter is obviously 5. So I machined a really tight pocket for that bearing, and then the bearing provides essentially a seal to the shaft. I did find it was slightly better when you put a little bit of even just Vaseline on the shaft before you put these on. And same with the Juki nozzle holder itself, just a little bit of like Vaseline or something on the shaft. Obviously the ultimate thing would be like green Loctite, but you wouldn't have a lot of fun taking it apart if you had to after that. So this is the results just based on that and just using a little bit of Vaseline. It made a noticeable difference, but it wasn't a huge difference with adding that. So first, just using this vacuum pump, just as a simple way to compare them, we're going to connect it to the old style one, and I'm not going to, it's got a Juki nozzle loaded, but I'm not going to plug the end yet. So we'll just see what the vacuum gauge does. So as you can see, maybe it goes up like 1 inch. And then if I just take my thumb and I plug the end of the nozzle, we'll do it again, and it's better, so maybe like 2 or 3. So now we can compare that to the new style. So again, not plugging the bottom yet, and so you can see it's like, it's going to like 6 or 7 on the scale, but it's at least 3 or so below. So anyway, I'd say it's close to 10, even just as that is. And now if I just take my thumb and plug this, it's not a heck of a lot different, but it's, we could safely say it's around 10, just for argument's sake. Now, interestingly, anyway, just based on that, I'd say it's, it's safe to say it's about 8 to 10 times better sealing, we'll say. As you can tell, it doesn't hold a vacuum, but I think it would be really hard for us to come up with something that held a perfect vacuum and didn't apply too much drag to the steppers. These are obviously very weak, so they don't take much, and this bearing, luckily, it doesn't add very much drag to it. It's not noticeable when you rotate things by hand, which is good. So, interestingly, I also know there's been some discussion lately about worrying about the sealing through the actual nozzle holder itself. So, if you kind of remember where the gauge went to before, now, this wasn't even actually done up, but we'll take it off and just plug this with our thumb. So now we've completely removed the Juki nozzle holder from the equation, and as you can see, it's barely better. Like maybe 1 inch of mercury better. Maybe. I don't even know if it's that. So that kind of shows that, unless you're involved with this kind of stuff, you probably wouldn't believe how hard it is to make a part like this to the tolerances that we have been guaranteeing. And based on that, the fit of everything is so precise that there isn't really a lot of opportunity for leakage. And one of the other things we do when we assemble this, you can actually see the balls if you pull it back far enough. When we assemble these balls do go in with dielectric grease, which obviously will help sealing. It's actually just for assembly. That's the reason why we do it, but it has the added benefit of sealing. But this bore here, like I'm not even sure if that would matter, but this bore is so nice, like the shaft fit here, that I don't think you'd get much air leakage through there even if you didn't seal in that area. So it's a very precise fit. These are machined. Now we're using a Swiss style CNC lathe machine shop in California that a friend of mine, his dad is kind of the head machinist there. The machines that turn these, I don't want to even hazard a guess. They're probably $300,000, $400,000, $500,000 lathes to guarantee the run out between these two bores. So it, you know, machines it on the one side first and does the bore, and it actually comes over with another sub spindle, grabs it, and then finishes the part on the back side. It's really quite amazing. Next time we do a run, I'll actually ask them to do some video, because these machines are incredible. If you've never seen a Swiss style lathe in operation, it's it's just one of those things you could probably just sit and watch for hours, because it's pretty amazing. So anyway, I think that's the end of the video and the end of what I wanted to show you. So yeah, the new style vacuum adapters, you know, solid 8 to 10 times better in my opinion. When I get a vacuum pump, which is coming next week, I'll do some other tests and see how much vacuum it holds while a pump is running, that kind of stuff. But I think this is a big improvement. And also we kind of went over vacuum leakage through the nozzle holder itself, which is practically negligible, so I'm not sure how much we need to worry about that. I actually did prepare for O-rings to go in the bottom of these to seal against the nozzle flange, but I don't even think it's worth messing around with that. So anyway, those were the main takeaways from this video, and I will update some design files on the site too, so people can make these themselves, either machine them themselves, or it's probably also just as easy to 3D print these. So I'll try and get those up on the website as soon as possible, and also I've machined a whole bunch of them as well, so they're available in the store if you guys want to actually just buy them. Alright, well, I hope this video is useful, and I'll talk to you guys later. Bye.